Hello and welcome all to first PUC Tungal online classes. Now in this session we will discuss the NCERT numericals. Let us go the numerical number 1. Numerical is the triple point of neon and carbon dioxide are 24.57 Kelvin and 216.55 Kelvin respectively. Express these temperatures on Celsius and Fahrenheit scale. Andrari namaga neon da matta carbon dioxide da triple point kottano avana Kelvin olaga kottano avane ಏನು ಮಾಡೋಣವ degree ಒಳಗೆ explain ಮಾಡೋಣ ಆಮೇಲೆ express ಮಾಡೋಣ ಆಮೇಲೆ Fahrenheit ಒಳಗೆ express ಮಾಡೋಣ. Shall I take here? Look at me. What is given? The triple point. Shall I go solution? Triple point. Triple point. TK is given. For neon I will T1K. Triple point of neon 24.57 Kelvin. Right. Then for carbon dioxide T2K equal to how much? 216.55 Kelvin. What we need? Both these temperature I need to express in terms of degree Celsius and Fahrenheit system. Right? Shall I go here? We know that first of all there is a relation between degree Celsius and Kelvin and degree Celsius and Fahrenheit system. Before that, see here the relation between degree Celsius and Kelvin. Tc is equal to how much? Tc is equal to Tk minus 273.15. Shall I call it as equation number 1? Relation between degree and Kelvin. Now let us go the relation between degree Celsius and Fahrenheit. See here, in the Fahrenheit the temperature can be expressed by Tf. It is 9 divided by 5 into bracket how much? Tc plus 32. Shall we call equation 2 now? Right. Now let us express for neon. I need to express this temperature in degree and Fahrenheit. See here. For neon I will take for neon already this equation how to write? See here, Tc equal to how to write? Tc equal to T1K for neon plus 273.15. Then Tc T1K how much? It is a 24.57. See here, this relation, this one minus 273.15. Then in a degree Celsius, how to obtain in the degree Celsius? Let us here calculation. For this I can write minus 248.88 degree Celsius minus 248.88 degree Celsius. See here, minus 248.58, not 88, like this. Again let us express this temperature in Fahrenheit. In Fahrenheit, how to explain in the Fahrenheit? The Fahrenheit Tf is available. This relation 9 by 5 how much? 1.8. Tc mean this value minus 248.58 plus how much? 32. Look at this equation 2. Again let us go solution of this. For neon, how much value we are getting? For this value nearly we are getting minus 415.44 Fahrenheit. Minus 415.55 Fahrenheit. This is for what? This is for neon. For neon Kelvin temperature is this much, then degree Celsius must be this much, Fahrenheit must be this much. Then we need to solve the one more here. The one more I can take for carbon dioxide. Shall I go for the carbon dioxide? Look at me. For carbon dioxide, shall I see? For carbon dioxide, look at me. What is the Kelvin temperature? 216.55. Then say in degree how to write? Tc is equal to how much? T2K, because I represent T2K for carbon dioxide, minus 273.15, right? Minus 273.15. Then TC, T2K how much? It is a 216.55 minus 273.15 degrees Celsius. Let us go for calculation. How much value we are getting? Nearly we are getting minus 56.60 minus 56.60 degrees Celsius. This is for carbon dioxide, right? Then in Fahrenheit, how to express this temperature in Fahrenheit? Look at this relation, Shall I take here? TF I will represent. TF is equal to 9 divided by 5 into TC mean this value minus 56.60 plus how much? 32. 9 by 5 is nothing but 1 by 8. Then this Fahrenheit temperature can be replaced. How to replace? It may be minus 69.88 Fahrenheit. Minus 69.88 Fahrenheit. This is the one of the numerical, right? This is the numerical one. I mean, the temperature in Kelvin can be expressed in terms of degree, in terms of Fahrenheit for neon and for carbon dioxide. The Kelvin temperature can be expressed in degree and Fahrenheit system. This is one of the numerical. Copy this numerical. We will go for the next numerical. See here. Right, students, shall we move for the second numerical for the NCERT? Look at me. The second numerical is the triple point of neon and carbon dioxide are. Triple point of neon and carbon dioxide. This is numerical number 1. Shall I go for numerical number 2? The two absolute scales A and B have the triple point of water. Two absolute scales. Absolute scale means 273.15. Two absolute scales of triple point of water defined to be 200A and 350B. Then what is the relation between TA and TB? Question is very simple. Question bar simple adari. Two absolute scales of A and B of triple point of water defined to be 200A and 350B. What is the relation between TA and TB? Here important point is to obtain solution for this. I need to know the relation between ATA, BTB. ATA and BTB. Simple is here. At triple point, the temperature at A point must be equal to temperature at B point. See here. Shall I go for solution for this? How to write solution? Look at me. At triple point, the product of point A and the temperature, the product of point A and temperature must be equal to the product of point B and the temperature BTB. Are you following this? At triple point, absolute scale temperature must be equal to this point A and absolute scale temperature must be equal to the point B. Now, from this equation, how to write? From this equation, I can represent TA divided by TB. TA divided by TB. TA divided by TB must be equal to B divided by A. Let us call it as equation number 1. Right? But in question what is mentioned? Two absolute scales of A and B have the points 200A and 350B. Two absolute scales. At absolute scale, 2 points are there. Absolute scale means 273.15. See here. At absolute scale, 273.15 equal to how much? 200A. At absolute scale, 2 points are there. See here. 273.15 is equal to 200A, or I can write 273.15 is equal to how much? 350B. 350B. Are you following this? At triple point to absolute scale. Absolute scale ಒಳಗೆ ಎರಡು ಪಾಯಿಂಟ್ ಅದ. ಈ absolute scale ಒಳಗೆ ಈ ಪಾಯಿಂಟ್ ಅದ, ಈ absolute scale ಒಳಗೆ ಈ ಪಾಯಿಂಟ್ ಅದ. Just compare this to what you are getting from this. 200A must be equal to how much? 350B. Right or wrong? 200A is equal to 350B from this two, or from this I can write the B divided by A. What is B divided by A? B divided by A equal to 200 divided by 350. 200 divided by 350 shall I call? It is equation number 2. Now very simple. Put equation 2 in equation 1. What you are getting? See here. TA divided by TB. TA divided by TB. B is how much? 200. A how much? 350. A is how much? 350. Then TA and TB in what ratio? They may be lying in the 4:7 ratio. This is equal to 4 divided by 7. Are you following? Does it correct or not? 200 divided by 350 is equal to 4 divided by 7. Then the TA and TB are lying in the ratio. TA and TB are lying in the ratio how much? 4:7. So this is the relation between TA and TB. Again copy this numerical. We will move for the one more numerical. Right. Shall I go for the new numerical? Look at me. One more numerical I can take. See here. The electrical resistance in ohm of certain thermometer. Electrical resistance of ohms. Resistance in ohms of thermometer varies with the temperature according to this relation. R is equal to R naught into bracket 1 plus alpha into T minus T naught. I mean resistance of conductor increases with the temperature. This is given by this relation already as given. The resistance is found to be 101.6 ohm, not W, it should be ohm. 101.6 ohm. At triple point of water 273.16 Kelvin. I mean resistance of conductor is this much at this temperature, and 165.5 ohm at a melting point of lead 600.5 Kelvin. Very simple. At this temperature, at this resistance, this temperature available. At this resistance, this much amount of temperature available. Then what is the temperature when resistance is 123.4 ohm? Very simple. Shall I take here? The resistance of conductor changes according to this relation. Resistance of this conductor R is equal to how much? R naught into bracket 1 plus alpha into T minus T naught. Right? Shall I call this equation number 1? Right or wrong? What is given? The temperature R naught given. What is temperature? Sorry. Resistance R naught given. R naught is equal to 101.6 ohm. It is not W, should be replaced by ohm. Then at what temperature? Temperature T naught given. How much? It is 273.16 Kelvin. Right? Then at this resistance 160.5 at R, how much? 165.5 ohm. The temperature is found to be how much? Melting point. Melting point means more temperature. 600.5 ohm. Right? What in it? What is the temperature when resistance is 123.4 ohm? I mean, what is the temperature when resistance is how much? Resistance is 123.4 ohm. It is very simple. Numerical is very simple. Andre ಈ resistance ಈ ಟೆಂಪರೇಚರ್ ಅದ, ಈ resistance ಈ ಟೆಂಪರೇಚರ್ ಅದ. ಹಂಗಂದ್ರೆ ಈ ಟೆಂಪ್ರೇಚರ್ಗೆ ಇಷ್ಟು ರೆಸಿಸ್ಟೆನ್ಸ್ ಈ ರೆಸಿಸ್ಟೆನ್ಸ್ಗೆ ಇಷ್ಟು ಟೆಂಪ್ರೇಚರ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಅಂದ್ರೆ ಒಂದು ಕಂಡಕ್ಟರ್ ಕೊಟ್ಟಾನ್ರಿ, ಅದು ಕಂಡಕ್ಟರ್ದ ಟೆಂಪ್ರೇಚರ್ ಎಷ್ಟು ಕೊಟ್ಟಾನ, T0 ಕೊಟ್ಟಾನ, ಅವಾಗ ರೆಸಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟದ, ಇಷ್ಟು ವ್ಯಾಲ್ಯೂ ಅದ. ಅದು ಟೆಂಪ್ರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿವಿ, ಮೆಲ್ಟ್ ಮಾಡಿದಾಗ ಎಷ್ಟದ, ಇಷ್ಟು ಟೆಂಪ್ರೇಚರ್ ಅದ, ಅವಾಗ ಅದು ರೆಸಿಸ್ಟೆನ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ಯದ. ಹಂಗಂದ್ರೆ ಈ ರೆಸಿಸ್ಟೆನ್ಸ್ಗೆ ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಟೆಂಪ್ರೇಚರ್ ಅವೈಲೇಬಲ್ ಇರ್ತದೆ. ದ ಸೊಲ್ಯೂಷನ್ ಈಸ್ ವೆರಿ ಸಿಂಪಲ್. ಐ ಕ್ಯಾನ್ ಸೇ ಹಿಯರ್ ಆಲ್ರೆಡಿ ಹ್ಯಾಸ್ ಗಿವೆನ್ the resistance value here. Look at me. What is the resistance value? The resistance value already given, R is equal to R naught into bracket 1 plus alpha T minus T naught. Right? Then see here. From this, shall I calculate alpha? I don't know value of alpha. First I need to calculate the value of alpha, then further we will move. See here. Shall I take here alpha? R is equal to R naught into bracket 1 plus alpha into T minus T naught. R is given. R how much? R is equal to 165.5. R naught 101.6 into bracket 1 plus alpha T. What is T? 600.5 minus 273.15. Are you following this? Again, shall I solve here alpha? 165.5 whole divided by 101.6 equal to 1 plus alpha, this value 600.5 minus 273.15. How much? 327.34. It is 327.4 or 327.34. 34. Right. Again from this you can calculate alpha values. Here just solve the value of alpha. Alpha is found to be nearly 1.92 into 10 raised to minus 3 per Kelvin. This is the value of alpha. Are you following? Does it correct this answer? 1.92 into 10 raised to minus 3 per Kelvin, or you can call per degree Celsius. Now you found the value of alpha. Now I need to calculate at this resistance what is the temperature. ಹಂಗಂದ್ರೆ ಈ ರೆಸಿಸ್ಟೆನ್ಸ್ಗೆ ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಟೆಂಪ್ರೇಚರ್ ಅವೈಲೇಬಲ್ ಅದ ಅದನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ರೈಟ್. ಸಿ ಹಿಯರ್ ದಿಸ್ ಇಕ್ವೇಷನ್ ಐ ಕ್ಯಾನ್ modify. How to modify this equation? Look at me. Now simply R can be replaced by R dash, R naught keep it up same into bracket 1 plus alpha, T can be replaced by T dash, T naught. Right. I mean R can be replaced by R dash, T can be replaced by T dash. At this resistance, what about this temperature? Our calculation. Now just put the values. R dash given already. How much R dash? 123.4. R naught already is there. 101.6 into bracket 1 plus alpha. Alpha already is there. 1.92 into 10 raised to minus 3. 1.92 into 10 raised to minus 3 into bracket T naught. How much? 273.16. Right. Or can solve. See here. 123.4 whole divided by 101.6 equal to. See here. Equal to how much? 1 plus 1.92 into 10 raised to minus 3 into bracket T minus 273.16. Are you following this? Right. Again, if we go for the solution directly, the T value is found to be the T value. Let us go for calculation. The T value I need to calculate. From this maybe the T value is 384.61 Kelvin. From this T value must be 384.16 Kelvin. Just go for calculation. See here. Very simple. 123.4 divided by 101.6 minus 1 equal to this value, or whatever value obtained divided by this value equal to T minus 273.16. Then calculate the T dash, not T value. That is what value? T dash value. Right. T dash value is, I mean, at this resistance this much amount of temperature exists for the material if we increase the temperature. Again solve this. Let us go for the further numerical. Okay students, the next numerical is a large steel wheel is fitted on the shaft of the same material. A wheel is fitted on a shaft of same material at what temperature? At 27 degrees Celsius, the outer diameter of the shaft is 8.70 centimeter and diameter at the central hole in the wheel is 8.69 centimeter. At 27 degrees Celsius, outer diameter of the shaft is this much and inner diameter of the shaft is 8.69 centimeter. Shaft is cooled using dry ice. Cooled means temperature of the shaft must be decreased. Assume that at what temperature the shaft does the wheel slip on the shaft. At what temperature the wheel does slip on the shaft. Assume that the coefficient of linear expansion of steel is found to be 1.60 into 10 raised to minus 5 per Kelvin. See here, a wheel is there, the wheel is placed on a shaft. See here, the outer diameter how much given? Outer diameter D1 is equal to how much? 8.70 centimeter. 8.70 and inner diameter found to be how much? Inner diameter 8.69 centimeter. See here, the temperature is given initially. How much a temperature given? 27 degrees Celsius temperature given, right? Then he is asking at what temperature does the wheel slips on the shaft? Does the wheel slips on a shaft by cooling, by placing a dry ice? When dry ice active adu cool ageda. See here, again what is given? Alpha value given. What is alpha value? How much? It is 1.20 into 10 raised to minus 5 per Kelvin. Are you following this? Andre ಒಂದು ವೀಲಿನ ಒಂದು ಶಾಫ್ಟ್ ಮೇಲೆ ಇಟ್ಟಿವಿ, ಅದರ ಟೆಂಪ್ರೇಚರ್ 27 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅದ, ಅದರ ಔಟರ್ ಡಯಾಮೀಟರ್ 8.7 ಸೆಂಟಿಮೀಟರ್ ಅದ. ಅದನ್ನು ಕೂಲ್ ಮಾಡೀವಿ. ಕೂಲ್ ಮಾಡಿದಾಗ ಅದ್ರ ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಇನ್ನರ್ ರೇಡಿಯಸ್ ಅದ? 8.69 ಅದ. ಯಾವ ಟೆಂಪ್ರೇಚರ್ ಒಳಗೆ ಅದು ವೀಲ್ ಏನಾಗ್ತದೆ? ಶಾಫ್ಟ್ದಿಂದ ಸ್ಲಿಪ್ ಆಗ್ತದೆ. ಯಾವ ಟೆಂಪ್ರೇಚರ್ಗೆ ಕೂಲಿಂಗ್ ಮಾಡೋಣ ಅದು ಡಯಾಮೀಟರ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ, ಹೀಟಿಂಗ್ ಮಾಡೋಣ ಡಯಾಮೀಟರ್ ಎಕ್ಸ್ಪಾಂಡ್ ಆಗ್ತದೆ. ಆನ್ ಹೀಟಿಂಗ್ ಡೆಫಿನೆಟ್ಲಿ ಡಯಾಮೀಟರ್ ಇನ್ಕ್ರೀಸ್, ಆನ್ ಕೂಲಿಂಗ್ ಡಯಾಮೀಟರ್ ಮಸ್ಟ್ ಬಿ ಡಿಕ್ರೀಸ್, ರೈಟ್? Now see here, we know that how to obtain this relation. He has given diameter. Students, in terms of length already is there. The change in length directly proportional to original length, directly proportional to change in temperature, or change in length is equal to some constant. See here, according to coefficient of linear expansion, change in length directly proportional to original length, directly proportional to change in temperature, or some constant alpha. In terms of length, then I need in terms of diameter. How to replace this in terms of diameter? Shall I call here? In terms of diameter, this equation can be replaced. See here, in terms of diameter, change in diameter equal to original diameter into change in temperature into alpha, constant alpha, right? Are you following this? Then I need temperature T. How to write this change in diameter? It is final diameter minus initial diameter. What is final diameter? D2. What is initial diameter? D1. Then shall I call it is D2 minus D1 equal to D1. What is alpha? Keep it up same. Delta T mean final temperature minus initial temperature. Final temperature minus initial temperature. Again, see here, we know all the values. D1 is there, D2 is there, alpha is available, T0 is available. Then I can calculate T value directly. How to calculate? D2. What is D2? 8.69. What is D1? 8.70. What is D1? 8.69. Alpha already is given. Where is alpha? 1.20 into 10 raised to minus 5. T minus T0. T0 how much? 27 degrees is there. Convert this into Kelvin. Plus 273. That's what shall I put T0 directly in Kelvin? 300 I am making. Right. Just go for calculation. This value is how much? Minus 0.01 equal to how much? 8.69 into 1.20 into 10 raised to minus 5 t minus 300, or can call t minus 300 equal to minus 0.01 whole divided by 8.69 into 1.20 into how much? 10 raised to minus 5, right? Just make the simplification, then you are getting the final temperature T. The final temperature T is found to be 204.21 Kelvin. See here, final temperature is 204.21 Kelvin. This is the final temperature. I mean, when temperature is cooled down, the shaft is falling by what temperature? By this much, by negative value actually it is. See here, shall I take minus 204.21 Kelvin minus, because here minus sign is there. If the temperature of the shaft is decreased gradually, then will slip down by this temperature. Again copy this numerical. We will move the one more numerical. Right. Next numerical is numerical number 6. Shall I take here? A hole drilled in a copper sheet of diameter 4.24 centimeter at 27 degrees Celsius. A hole is drilled in a copper sheet of diameter, which hole diameter is 4.24 centimeter at 27 degrees Celsius. What is the change in diameter of the hole when the sheet is heated to 227 degrees Celsius? Change in diameter I need. The coefficient of linear expansion of the copper is 1.70 into 10 raised to minus 5 per Kelvin. Question is very simple. I can solve it. See here, what has given? The hole drilled in a copper sheet. The diameter of the hole is found to be 4.24 centimeter. See here, solution. Directly I am moving for solution. Solution here. What solution? The hole drilled in a copper sheet. D1 is hole. How much? 4.24 centimeter at what temperature? T0 temperature. How much? 27 degrees Celsius. Right? Then, what is the change in diameter of the hole when it is heated to 227 degrees Celsius? I need a change in diameter. Change in diameter when the temperature is how much? 227 degrees Celsius. What is given? Alpha value given. How much alpha value given? 1.70 into 10 raised to minus 5 per Kelvin. Right? ಒಂದು ಕಾಪರ್ ಒಳಗೆ ಒಂದು ಹೋಲ್ ಡ್ರಿಲ್ ಮಾಡಿವ್ರಿ, ಅದಕ್ಕೆ ಎಷ್ಟು ಡಯಾಮೀಟರ್ ಅದ, ಇಷ್ಟು ಡಯಾಮೀಟರ್ ಅದ, ಇಷ್ಟು ಟೆಂಪ್ರೇಚರ್ ಒಳಗೆ. ಹಂಗಂದ್ರೆ ಆ ಹೋಳದ ಎಷ್ಟು ಡಯಾಮೀಟರ್ ಚೇಂಜ್ ಆಗ್ತದೆ? ಯಾವ ಟೆಂಪ್ರೇಚರ್ ಒಳಗೆ? ನಮ್ಗೆ 227 ಡಿಗ್ರಿ ಒಳಗೆ. ರೈಟ್? Again students, we know that the change in diameter directly proportional to original diameter, directly proportional to change in temperature or constant alpha. How to replace? Change in diameter equal to original diameter into change in temperature into constant alpha. Right? Again how to replace? Change in diameter equal to original diameter into alpha. Delta T is what? Final temperature minus initial temperature. Right or wrong? See here again. How to replace? Change in diameter. Original diameter how much? It is 4.24 centimeter. 4.24 alpha. 1.70 into 10 raised to minus 5 T. T is how much? 227. T naught 27. Are you following this now? Then again change in diameter you can replace. How much? 4.24 into 1.70 into 10 raised to minus 5 into how much? 200. Into 200. Then from this I can get the change in diameter. change in diameter is found to be 1.41 into 10 raised to minus 2 centimeter. Minus 2 centimeter. This is change in diameter when the temperature of the hole is increases to 227 degrees Celsius, when the initial hole was the diameter 4.24 centimeter at the temperature T0. So these are the few numericals. We will continue these numericals, few more numericals in the next class. Now prepare all these numericals and prepare for also the next numericals. Okay students, let us know the few numericals in the next class. Thank you.